Thank you.
Certainly. Thank you very much, Maria Felice, and thank you very much for the invitation. Just to have a confirmation that all is well, and then you can see my slides.
Yes, it is perfect.
Very well. Okay. This is very much a joint work with the Joint Research Center and of the European Commission, between the University of Parma, also London School of Economics, and the Joint Research Center. Let me start presenting the results, some of the results that have been obtained from this cooperation. You see the amount of money that we are talking about. And let me start with the sentence of the Court of Justice of the European Union, where UK has been fined with a little bit less than 3 billions. Actually, 3 billions, not 3 millions. So it said, the court said the method based on statistical data is allowed, you see, is permitted. This method is permitted. So the method has proved to be precise and reliable. Now I want to talk, because we heard a lot about monitoring, I give you some additional details. And, I wanted to do a live presentation, and in order to show you why you need robust statistics. For example, let us start with the simple regression. Well, it doesn't matter which variables you are. You see, which variables you have. You see that all these points, everything is on a regression line. Everything is fine. Then you suppose now that you have just one outlier here. You see that there is a point which deviates from the main regression line. Well, if there is just one outlier, if you do a traditional fit, this is what you get, that this line is attracted by this outlier. Of course, what you want to do is a sort of robust fit, something which remains inside the bulk of the data, which is not affected by the presence of these outlying observations. So now let me see if you have 3 outliers. One is here, and the third one is over there. These 3 outliers. Now, if you do a traditional fit, and this is what you get. These 1, 2, 3 observations, they have completely changed the slope of the regression line. Once again, you want to have a robust fit. I mean, something which stays here in the bulk of the data, because these are observations which are atypical, but you not only have to identify them, you have to understand what is the effect that they have on your model. So maybe now you think that the examples here that I've shown are very naive, in the sense that you say, but these outliers can be immediately spotted, even by eye. Now, let us see now a more, let us say, a more complicated example. You see, here you have a response and 3 explanatory variables. It seems that there is a positive relationship between y, x2 and x3, and not so clear what happens for x2. What most people will do something like this. That is to fit a regression model. That is, you have your estimates of the parameter, your t-statistics, or the p-values. And then you check the R-square, and then you say everything here is fine. Or what people will do this traditional QQ plot of residuals, and then you see that everything here is fine. All the units are inside the envelopes. Or another plot that people traditionally do are the plot of residuals against fitted values. Well, with the passing of the years, I think that these plots are really very, very uninformative. Anyway, I take responsibility for what I'm saying. So you see from this plot, you don't know at all what is the connection between this unit and these units. You don't know whether there are subgroups in the data. For example, you see this 43, but this value does not say anything. You want to see what is the connection among the different units. And well, now this was the traditional way of doing statistics. Now I tell you what is the traditional way of doing robust statistics. Here you have, in robust statistics, we have the concept of breakdown point. That is the percentage fraction of observations that can go to infinity and your estimator is bounded. That is the proportion of observations that you are allowed to discard. And then here you see that if you use these two different values of breakdown point, you have a pattern of residuals, which is very different. You see that here, using this breakdown point, this parameter 0.25, you observe that unit 43 has a very large residual. If you have breakdown point 0.5, you observe that a lot of units with large residuals take place. Of course, you can't go in court and say, look, if I use a set of parameters, then I obtain these results, and then you are in front of the judge, and then the other person say, well, but if you have different parameters, you obtain completely different results. So well, you know, in our software, everything is brushable in the sense that you can see the position of these units in the y-axis plot, and then you see these units y, they have a larger residuals, because in the plot of y against the column of x, these they do not look as outline observations. And but why then? Well, what we have developed over the years is this concept of monitoring. And so here you check how the residuals change as you change the breakdown point. This is really an informative plot. And so each trajectory refers to a unit, a row of the X matrix. So each one is a particular unit, a particular trajectory. So you see that you can clearly see that these ones they form a group, and then unit, this is unit 43. Unit 43, that this unit has a residual which is very, very small, and then starts with a very, very large residual. This is in statistics what we call a swamping effect. But in practice, the idea is to have, rather than working with all of units, to work with a subset of the units. That is to observe what we call a movie and to see how the residual, each unit here is a residual, and to see how the residual changes during this movie. Because 99% of the people just see these residuals at the very end, when all the observations are included. On the other end, you see, if we have 20, this means that we have 20 observations in the subset. If we have 25, these are 25 observations in the subset, but we have the residuals for all the observations. Look at these 25 units that have a residual which is very, very small. On the other end, at the end, they have a residual which is very, very large. Once again, 99% of the statisticians will look just at these values here, the trajectory, I mean, not the overall trajectory, but just the final step. So you see how the residuals, they do change in this movie. Okay, let me now go get out. So if you see these units that have a very large residuals, that at the end they have a very small residue. If you brush these units, well, you say, but why these units are outlying? Why do they form a group? And then the fact that they form a group, you see that they have trajectories which are very, very similar. Now, let me do this plot, which is a three-dimensional plot. The red are the outliers, but the outliers look completely inside the bulk of the data. But look, But now you see why these units are outliers. Depends on your point of view. Here they seem completely inside. Here you see that they are completely outside. Therefore, the message here is, it is important to have monitoring, to understand the effect that each unit has on your model, and also to understand what are the variables which are most important. Now, as concerns variable selection, in statistics, we have the so-called t-statistics, the importance of the variables. And this is the table that we look, the p-value. Once again, these numbers do not mean anything at all if there are outliers, because the most important variables can be affected and can be affected by the presence of outlying observations. Therefore, or if you exclude, for example, one unit, observation 43, if we use observation 43, let me see what happens, that you have, that this variable becomes negative and significant. You see the p-value close to 0.05, and then the t-statistics is close to -2. Now, why not to do a monitoring and see the value, the trajectory of the t-statistics? Remember now that before we were seeing just the final value here. On the other end, you see the overall trajectory. From the overall trajectory, you can immediately see that the t-statistic for the first variable is positive and significant. Then there are the outliers. When the outliers enter in this journey, in this subset size which increases, then the t-statistic of this variable changes from positive to negative, negative significant value. And now let me do a zoom of what happens here. Something which is positive, and then the introduction of the outliers, and then the sign is completely changed. Therefore, stability, monitoring, and so on and so forth. And now let me go back to the presentation. The next 10 minutes will be dedicated to correspondence analysis. And also in correspondence analysis, that is a technique that has to do with contingency table. That you want to understand the effect of each unit. This part of the talk comes from this paper. And let us see this motivating example. So you have the 28 European countries pre-Brexit. Then you have 5 variables. These are the classification given by the Joint Research Center of the European Commission according to these 5 price segments. And you see, this means 66 means that for 67 means that for 67 times Bulgaria has traded with the level of price which is X1. So here you want to see what is the association between countries and level of price. There are particular countries which are mainly associated with level of price X5, X4, or X2. What is the association between the particular row and the particular column? Okay, there is a significant association. Well, I've seen that the other presentations were not very technical, so I will just show you now the online, the live, because everything that I'm presenting here is fully reproduced with our FSDA toolbox, which is fully downloaded, and everything is commented, everything is also in GitHub. And this is the where I load the data. I load these clots. These clots are here. This is our table. I load these clots, and then I call our routine for correspondence analysis. So this is the routine for correspondence analysis. You see, what has been done so far in correspondence analysis may be different way of visualizing the data. And then you see that the correspondence analysis, you see this latent dimension is the level of price. You see X1, X2, S3, S4, S5. And correspondence analysis in the past had been used just as a descriptive tool, in the sense that you had supplementary rows, some rows that you could remove from your fit, let me do reset, or you could do maybe some confidence ellipses to put some confidence ellipses on particular row points or column points. But that was a sort of let us say, correspondence analysis in a descriptive way. So you wanted to see what is the probability that this point is an outlying observation. What is the probability that SK is strongly associated with X1, not from the closeness of these 2 points. You want to have things that are embedded inside an inferential framework. And so that's this app has been completely written by us and together with the Joint Research Center. And as you have seen before, here, instead of working with all the rows, we work with a subset of the rows. So, and then here we want to see how the model changes, how the position of these units changes as you grow this subset size. And this is, you don't want to select in an arbitrary way what are the supplementary rows and the supplementary points, because you want to see how your model changes as this subset grows. Okay, you can have this. Now, let me do reset. And one thing that has to be noticed, that every statistician will notice. Here you see that the origin of the axis is clearly misplaced. It's clearly misplaced because the origin of the axis should be here, because this is the bulk of the data, the bulk of the European countries working with prices which are X3, X4, and X5. On the other hand, these are the outlying observations, but these outlying observations change the centroid. So the centroid is in between good observations and outlying observations here. On the other hand, if you work with a subset of the data, for example, you can see, look at the centroid, where the centroid is located. The centroid is located really deeply in the part of good units associated, in fact, with X4, X5, X3, and X2. And these are the stream units. Well, you can do everything in a fully automatic way, in a fully automatic inferential way, in order to detect in a fully automatic way what are the units which are detected as outliers. Here people who know in statistics know that the direction is subjective. So in the sense that this was the direction that you saw before from X1 to X5. These are the outlying units. And now, before I show you the plot of the residuals, but here is the same thing. This is the monitoring of the robust Malanobis distances. And you see here that there is the masking effect, in the sense that do not look at this distance in the final step, because it's the trajectory that you have to see. These are units that were good units that at the end, given that the outliers join the subset, they have a Malanobis distance with respect to the centroid. Here there are contingency table. Therefore, we are talking about profile rows with respect to the profile centroid. And you see these outlying observations. Okay, that was just to give you an overview of what we have done. Therefore, I will skip all the formula, but just to tell you what was the goal. The goal here is to skip the outlying rows. The goal is to have a centroid which is not affected by the presence of outlying observations. Then you can, I will skip this part. So this is the traditional and robust correspondence analysis plot that with the outliers detected, that you see now all the prices that they overlap more closely. On the other end, here there is the problem that this outlying observation attracts the centroid. So this is the centroid which is misplaced. This is the centroid on the other end which is inside the bulk of the data. Well, then this is scatter plot of the row profiles, and then everything here is inside this app. That everything is fully downloaded, and so the idea of monitoring that I've presented is not just to use a prefixed value of breakdown point, but we want to use as many observations as possible. And so I will skip just this part, and this is the plot that I've already shown you before. This is the monitoring of the Mahalanobis distance. You see that as the subset size grows, as the outliers enter this for search, and then you do not have to observe just these final values, but you have to understand what is the effect that each unit has on your model. And this procedure is particularly suited for anti-fraud purposes, because you have to understand how your model changes if there are the outliers, there are not the outliers. Then you have this technique for automatically understand what are the countries that are atypical with a particular confidence level, and everything is in GitHub, so that everything is fully visible. In our code, there are not calls to external routines. This is the QR code. Just if you want to, with your mobile, you want to take a picture of this QR code. This is the documentation that we have, because everything is really fully documented. You see, these are the documentation, all the functions, what this function does, and so on and so forth. Then we have the tutorials, yes, the data set, the function, and everything, and so on and so forth. Now, the key message of this talk is that you may think that masking and swamping effect are just something which is referred to regression of multivariate analysis. No. They are also, this phenomenon, these outlying rows, outlying columns are also present in the context of correspondence analysis. Before the correspondence analysis, this technique was just used in a descriptive way. On the other hand, we have provided an inferential framework in order to understand with a particular robust confidence level what is the probability that this unit is outlying observation. Through monitoring, we can evaluate the effect that each row has on the fit. And there is a forthcoming book, me and together with Professor Anthony Atkins, together with the JRC, about this concept of monitoring. Then the next step will be an extension to multiple correspondence analysis.